Welcome to the deep dive. This week, we are really trying to cut through the noise in the AI and robotics world. There's just so much happening.
There really is. We've sifted through a pile of sources, and what jumps out is, well, the sheer scale of money involved, some truly cutting-edge science breakthroughs, and also some governance challenges that are, frankly, pretty complex, almost invisible to many companies right now.
Yeah, invisible is a good word for it. It feels like things are accelerating incredibly fast.
Exactly. So for you listening, we've broken this down into three main areas to make sense of it all. First, we'll look at the engine room, the chips, the power demands, the money flowing in, the real infrastructure.
Got it. The foundations.
Then second, we'll shift to how software is actually being built now, this move towards AI agents and the hidden governance problems that come with it.
Okay, agents and governance.
Yeah.
And the third piece.
And finally, we bring it back to the physical world. Robots in the home, believe it or not. The materials making them possible. And also how old company data, legacy data, is suddenly super valuable in this AI era.
Right, data as the new oil kind of thing. Okay, let's dive in. Starting with that massive scale you mentioned, the money. Nvidia has to be the starting point.
Absolutely. I mean, the numbers are almost hard to grasp. Nvidia just became the first public company ever to hit a $5 trillion market cap.
5 trillion, and the speed is just staggering. Didn't they just hit $4 trillion?
Just 3 months ago. It's incredible acceleration. The stock's up something like 50% this year alone.
And crucially, this isn't just market speculation, right? This is driven by actual intense demand.
That's the key. CEO Jensen Huang is talking about potentially $500 billion in AI chip sales down the line. And you see this demand in huge projects, like the 7 new supercomputers they're helping build for the U.S. government.
For things like national security, energy research, these aren't small projects.
Not at all. Each one needs thousands of their top-end GPUs. So the demand is very real.
But that leads directly to the next big challenge.
Yep.
Energy. All that computing power needs. Well, power. Lots of it.
It's a huge bottleneck, which makes this next bit quite interesting. One of our sources mentioned a startup, Extropic. They're claiming a potentially radical solution to this energy problem, not just an incremental improvement.
Okay, intriguing. What are they proposing?
They've developed a new chip architecture they call Thermodynamic Sampling Units, or TSUs. And the claim is pretty wild. They say these TSUs can run AI models using up to 10,000 times less energy than current GPUs.
Whoa, hang on. 10,000 times less energy? That sounds almost too good to be true, like you're breaking physics.
Yeah, it does sound like a cheat code.
So what's the catch? What are you giving up to get that kind of efficiency gain, accuracy, flexibility?
That's exactly the question. It seems they're not aiming for the same kind of high-precision, step-by-step calculation that GPUs do, which burns all that energy. Instead, the TSU works more on probability. Think of it like it estimates a very likely answer quickly based on the overall pattern, rather than calculating every single detail.
Okay. So it generates probable solutions, which is maybe all you need for a lot of AI tasks anyway.
Precisely. It trades that pinpoint accuracy for massive energy savings, focusing on statistical outcomes. And modern AI models are, fundamentally statistical.
If that works in the real world, that changes everything for data centers, for the cost of AI, huge implications.
It really could. And speaking of the hardware foundations, it's not just Nvidia making moves. Samsung had a massive comeback in its semiconductor business recently.
Right, I saw that. They broke a losing streak, didn't they?
Yeah, ended 4 quarters of decline, posted a big operating profit, PRW, $12.2 trillion. And connecting the dots here, the sources explicitly say this turnaround was driven by AI components, specifically high bandwidth memory, HBM3E chips, and server SSDs.
Okay, HBM. For those of us not building servers in our garage.
This is the brief on the premium content available from AI Now. Hey, so if you're enjoying what you hear on our daily show, right? Well, this premium stuff, it's basically your fast track. We're talking about taking all that AI knowledge and actually using it, like right away, moving you from just knowing things to really doing things with AI. Okay, so first up, the big thing is efficiency. You know how fast AI moves? It's crazy. Staying updated is tough. So what we do is cut through all that noise. We distill the really important trends, the tools, the strategies, give them to you straight, all actionable insights. It keeps you ahead without wasting any time. Second, what do you actually get? Well, for just $4.99 a month, yeah, less than a fancy coffee, you unlock a bunch of exclusive series you won't hear on The Daily Show. There's weekly deep dives with AI Now Educate, practical stuff on tools and business strats with AI Now Commercial, and even deeper analysis and frameworks in AI Now Conceptual. It's the whole package. And finally, we made it super easy and low risk to jump in. Seriously, it's totally beginner friendly. Alex and Jessica, you know them, they break down even the tricky stuff. Plus, you can give it a whirl for 30 days, grab those strategies, and if it's not for you, cancel anytime, no problem. Easy peasy. Bottom line, AI Now Premium gives you that complete, up-to-date knowledge.
Raj, quick reminder, why is high bandwidth memory so critical for AI?
Sure. So HBM isn't like the RAM in your laptop. It's memory stacked vertically, right on the chip package, very close to the processor. This massively speeds up how fast the processor can access data. And when you're training or running huge AI models, that data access speed is often the limiting factor. HBM removes that bottleneck.
Got it. Faster data access for these giant models.
Exactly. And Samsung is already mass-producing the latest version, HBM3E, and even shipping samples of the next-gen HBM4. The whole memory industry is being reshaped by AI demand.
So the hardware engine room is definitely firing on all cylinders. Money, potential energy breakthroughs, advanced memory. Let's shift up a level now to the software itself and how it's being created. You mentioned a new workflow focusing on agents. Cursor 2.0 came up.
Yeah, this feels like a fundamental shift in how developers might work. Cursor 2.0 is built around this idea of agents instead of just editing code files directly.
So agentic coding. You tell the AI what you want, not necessarily how to code it step by step.
Pretty much. You give it a goal. Build this feature, refactor this code, fix this bug. And the agent figures out the steps, which files to change, what code to write.
And they built their own AI model for this, called Composer. Why not just use GPT-4 or something?
Speed seems to be the main reason. They claim Composer is 4 times faster, aiming for responses in under 30 seconds. In coding, that low latency is crucial. If you have to wait minutes for the AI, you'll just start typing yourself. Fast responses build trust and encourage using the agent for bigger tasks.
Makes sense. And then there's this multi-agent strategy they're using. That sounded really interesting. It's not just one AI assistant.
Right. You can run up to 8 different AI agents in parallel on the same task.
8. So what's the point of that?
Well, the interesting strategy that emerged, especially for complex problems, is giving the exact same problem to multiple different models simultaneously. You might get 8 slightly different solutions or approaches. Then the human developer picks the best one, or combines ideas. It's like crowdsourcing the AI's creativity.
Leveraging the diversity of the models. Clever.
It potentially leads to more robust or creative solutions than relying on just one AI's perspective.
All right. Okay, now we have these powerful, fast AI agents potentially running inside company systems. This leads us straight into that governance problem you mentioned earlier, this shadow AI.
Yes, and this is where it gets genuinely concerning, even scary for businesses. Shadow AI is basically employees connecting unauthorized third-party AI tools to their company's official software.
Like connecting some new AI summarizer tool to the company's Slack or Salesforce account.
Exactly. Or a transcription tool to Zoom.
Yeah.
They often use their existing login credentials, their permissions, so it just works.
Yeah.
But IT has no idea it's happening. No visibility, no vetting.
That sounds like a recipe for disaster from a data security perspective. The sources had a specific example, didn't they? Reco and a big financial firm.
They did. It really highlights the scale. This Fortune 100 financial firm thought they had tight security. But Reco scanned their systems and found over 1,000 unauthorized third-party integrations. And the kicker,
Yeah.
over half of those were AI-powered tools the company knew nothing about.
1,000. Wow. And the danger isn't just that they exist, it's what they might be doing with the data they can access, right?
Precisely. The real smoking gun was finding one specific integration, an AI transcription tool someone had connected to Zoom. This tool was silently training its own external AI model on the content of the company's Zoom meetings.
Wait, so sensitive discussions, customer pricing, strategy talks, were being fed into some random third-party AI model?
Unknowingly, yes. With no security review, no contract, no control, that's the nightmare scenario. And Cisco data suggests this is widespread. Something like 62% of organizations lack visibility into employee AI use.
It's a massive blind spot, shifting focus from optimizing code to just trying to keep sensitive data from leaking out.
Okay, let's pivot again. Completely different direction. Physical robots. The dream of the home robot seems alive and well looking at 1X's NEO humanoid.
Definitely alive. NEO is pitched for the home about 5'6" stocks tall. They're selling it for $20,000. We're offering it like a subscription for $499 a month.
A robot subscription? Okay, but there's a catch, isn't there? It's not fully autonomous all the time. That's the really interesting, maybe slightly awkward part. When NEO gets stuck, encounters something new, freezes up a remote human operator, puts on a VR headset, and takes control.
So you pay for a robot, but sometimes you're getting a person driving it remotely.
Essentially, yeah.
Yeah.
They teleoperate the robot through the tricky bit.
Yeah.
It's a very 21st century solution to the current limits of AI.
Do we know if the human operator has to click "I am not a robot" before taking over?
Huh. Good question. Maybe it's in the terms of service.
But 1X frames this as a feature, right? A way to gather data and train the robot faster.
They do. They argue it lets them deploy sooner and learn from real-world situations handled by humans rather than waiting years for perfect autonomy. It's a pragmatic, if unusual, approach.
And it shows there's still huge investor confidence in this space. I saw Cruise founder Kyle Vaught has a new stealth robot company.
Yes, the bot company. Apparently building a non-humanoid home robot, but already talking about a $4 billion valuation, even before showing a product. The hype cycle is definitely spinning.
So the belief is the software is getting there, and the hardware needs to catch up. Which brings us to materials science. There was a breakthrough mentioned. Artificial muscles.
Yeah, really fascinating research out of UNIST. They've developed a tiny artificial muscle that seems to solve a classic problem in robotics.
What problem is that?
It's the trade-off between strength and flexibility. Usually materials are either strong but stiff or flexible and stretchy but weak. This new muscle can apparently switch between being soft and rigid.
Like a real muscle, but synthetic.
Kind of, but potentially much more powerful.
Right.
The numbers are pretty wild. A tiny 1.2 gram sample could lift 5 kilograms. That's like 4,000 times its own weight.
Oh.
And it has 30 times the work density of biological muscle tissue. If this scales up, you could have robots that move fluidly, like us, but have incredible strength.
That could unlock a lot of potential applications.
Okay, shifting gears one last time.
Mm.
Data. You mentioned legacy data is becoming valuable again. The AOL acquisition caught my eye.
Yeah, Bending Spoon's buying AOL from Yahoo. This isn't about reviving the AOL dial-up sound, obviously. Huh, probably not.
It's purely a data play. AOL still has around 30 million monthly active users. That's a huge data set of real human behavior. That data is gold for training AI personalization engines, improving ad targeting, understanding digital identity, things that are becoming incredibly valuable.
And the deal structure tells a story, too, right? It involved a lot of debt.
A $2.8 billion debt package, yeah. Which signals that lenders are becoming confident that these large established user data assets can be monetized effectively over the long term, even if the platform itself is old.
So the data itself is the valuable commodity, not necessarily the website or app anymore.
Exactly. The curated history of user interaction is the key asset.
Okay, finally, let's touch on the creative side. AI and music. There was a big settlement between Universal Music Group and Udio.
A really significant one. UMG went from suing Udio over copyright to partnering with them.
From lawsuit to joint venture.
Yes. They're launching a licensed AI music platform together in 2026. This could set a major precedent for how the music industry engages with generative AI, moving towards licensing and collaboration instead of just trying to ban it.
That sounds like progress, maybe? But there was immediate backlash from users, wasn't there?
There was. As part of the deal, Udio suddenly disabled the ability for users to download the songs they created.
Ouch. So people using it creatively, maybe downloading tracks for videos or remixes, suddenly couldn't.
Exactly. It instantly restricted their creative freedom. It highlights that tension between establishing legal frameworks for AI and users wanting open, unrestricted creative tools.
Meanwhile, OpenAI's video generator, Sora, seems to be expanding rapidly.
It is, rolling out across Asia, Thailand, Vietnam, Taiwan. Apparently, it hit 1 million downloads faster than ChatGPT did initially. The appetite for AI video is huge.
And they're adding features to make it more personal.
Yeah, things like cameos, letting you put yourself into the AI-generated scenes, and character cameos, where you can turn your pet, or even an object, into a reusable character in different videos. Making it easier to personalize is clearly key to adoption.
Okay, wow. We've covered a massive amount of ground here. From trillions in chip investment
to rewriting how software gets made with agents, the lurking danger of shadow AI.
New robots, new muscles, old data getting new value, and the shifting rules in music AI. It's a lot.
It really paints a picture of AI accelerating on all fronts simultaneously. The technology is moving faster than our ability to fully understand its implications, let alone govern it effectively or even power it efficiently.
So wrapping this up, what does this whirlwind mean for you, the listener? I think it underlines that this isn't just theoretical anymore. AI is reshaping infrastructure, workflows, security risks, even creative rights right now. And there's a final, quite sobering thought I want to leave you with. Connecting back to that energy and impact theme, it comes from ocean monitoring robots.
All right, the MBRI autonomous floats, they've been monitoring the deep ocean.
And they detected something deeply concerning. Marine heat waves are causing the ocean water to stratify to form distinct layers that don't mix well.
Which sounds technical, but the consequence is devastating. It cuts off nutrients to the plankton at the base of the food web. And crucially, it weakens the ocean's biological carbon pump, the natural process that absorbs about a quarter of all the CO2 humans release. That process relies on healthy plankton.
So these robots monitoring the planet are showing us a critical climate system breaking down, which leads to the big question. Will the incredible acceleration of AI, driven by all this compute and data we've discussed, help us find solutions to massive problems like climate change fast enough?
Or will the environmental cost of running the AI and the data gathered by our monitoring robots simply confirm the damage is happening faster than we can fix it?
It's a profound race between technological capability and planetary consequence. Definitely something to think about.
Indeed. The ultimate test, perhaps.
Thank you for joining us for this deep dive. We hope mapping these signals helps you navigate the rapid changes happening across the AI landscape.
Okay, let's unpack this a bit. If you've liked what you've heard from us so far, getting these insights. Well, we found this really interesting source this week.
Yeah, a memo, wasn't it? Called The Fast Track to AI Mastery.
Exactly. And what really jumped out at me was how they framed the problem.
Yeah.
It's the sheer speed. They literally say AI is evolving at lightning speed.
Right. And their whole pitch, really, is offering this structured way to keep up, to actually leverage it, not just read about it.
So it's not just about random articles or blog posts, which, let's be honest, can be overwhelming.
Definitely. They're arguing for something more deliberate, a system. It seems like this premium content they describe is built around that idea.
Yeah. And if you feel what you've learned so far is beneficial, this sounds like the next step. They talk about this premium access. What is it, like $4.99 a month?
Something like that, yeah. Less than a coffee, basically. And it unlocks 4 specific content streams.
Okay, so what are they?
Well, you've got your weekly and monthly summaries, just keeping you current. Then there's specific educational stuff. They call it AI Now Educate.
Right, for the deeper understanding.
Exactly. Then updates on the latest commercial tools and strategies, really practical stuff. And finally, the heavier part, these conceptual deep dives and frameworks.
That last one sounds potentially a bit much, especially if you're, say, a beginner or just moderately into AI.
You'd think so, wouldn't you? But that's where their guarantee comes in, apparently. The source memo is pretty clear on this.
How so?
They promise it's all absolutely beginner-friendly. They take complex ideas like the difference between fine-tuning and using a RAG system, right?
Okay, yeah.
And they break it down. They use analogies, real-world examples. The goal isn't just knowing the term. It's understanding why it matters, how you could, actually use it.
So it's application-focused. Less textbook, more toolkit.
Precisely. It shifts the focus from just knowing about AI to actually building strategies you can apply. The source really emphasizes that gaining stuff you can use at work or, just in your life generally.
It sounds like a curated path then, avoiding the information overload we were talking about.
That seems to be the core value proposition, yeah. For that small monthly fee, you get this distilled high-impact knowledge, structured learning.
So for you, the listener, it means getting past the jargon, getting actionable insights, and basically staying ahead without drowning in information. And they mention you can try for 30 days, cancel anytime. Risk-free, essentially.
Right. It makes you think, doesn't it? In a field moving this fast, maybe relying only on scattered free stuff isn't enough anymore to really get ahead.
That's a really interesting point.
Maybe this kind of focused, structured learning isn't just helpful. Maybe it's becoming essential. The source definitely leans that way. It argues the value of organization really outweighs that minimal cost.